Hi, in this tutorial I would like to introduce how to use Houdini to make the low-cost for effect in the game. I will do 3 short videos to cover this topic. So first we need to generate texture, then create the full shell geometry. In the end we need to integrate all the assets and prepare shader in the game engine, like Unreal and Unity. Before we start it, let's take a look at what is a full shell technique. Usually in the movie industry, the way they render fur by using strands is extremely expensive. It is a huge challenge to render those super high density splines under 33 milliseconds, which keeps 30 frames per second in real time with the current platform. Alternatively, instead of rendering each fur spline, we could consider the high density fur just as the volume. Then use a shell-based rendering technique which contains samples of those fur volume on any surface shape. The main idea of rendering with shells can be illustrated like this image. If we put a high density fur in a volume texture and represent it by slices on layer meshes that are covered on geometry closely, just like shells. One of the strengths of using shells is that the number of the layers may vary depending on the level of detail. We could optimize the fur performance easily. Giving less shell or removing it when rendering in distance can lower the cost on GPU side, which reduces the overdraw per pixel. There is another thing we need to know. This method is good for short fur, but not long one. When the fur becomes longer, the gaps between the shell layers will become very problem on the side. One of the solutions to fix this could be to simply increase the number of the shells, which lower the rendering performance for sure. However, instead of using more shells, additional primitives along the center of the mesh can be used in junction with shells to outbalance this weakness. For the more details, you could reference the paper Real-Time Fur over Arbitrary Surface and the integrating motion with the real-time fur simulated using shells and particle. I put the links in the video description. Okay, now let's start it from Houdini to make fur volume texture. So first thing we need to create a geometry, and dive in, create a grid. Default size, keep default size, then we do the scatter. We just need a 20 point here, and we do the transform to transform this point to the high position. It's like the tip for the fur, and merge them together. So now you can see we have a 2-point group. One on the bottom, I will use those points like root of the first spline, and the top will use as tip. So connect them as spline. Use hide the line here. So we need to make the polygon and use by group. You can see its mass, and we use by attribute, and nothing here because there is no attribute to tell the node which 2 points should connect together as a line. So we need to go back to the scattering, go to the output attributes. We need to create that. This source primitive, it just gives the ID number. It's like ID number for each point. So here in the geometry spreadsheet, you can see the source prim in the points. They have a unique ID for each point. So when we duplicate them, they keep this attribute. So we can use that to tell a node which one is should create line between which two point. So when the point have the same source prime number, so they will connect them, create a line. Okay, then we need add the resample node to add more point in the line. So how many point you need, it depends how many variation you want to create in the for. So it's related for you want this move to the different direction, or you want have different thickness. Actually, in this tutorial, what I made here is very simple clone shape. So I actually don't need point between the line, but I just show here. So in case you need to change the thickness, the shape, you can add as much as you want based on what you need. So here is one thing very important. We need turn on the curve U attribute. So in each line, they have a gradient from 0 to 1. It's a float. So in this case, the bottom is 0 and the top is 1. You can use visualize to take a look what value it is. If we go to the visualize and remove that, select the point. This you will see the value on the top is 1, and then we'll go to the 0. We have a gradient here. That order depends on how you generate this line. If I switch that, it should be revert, I think. Yes, but I want like that. Okay, so disable that. So next thing we need now we need to create the point warp. Davy. Here we need to bend the attribute which we created, the curve U. So here put in the curve U. Then we make sure the fit range here. I just want revert it. It's not necessary, you can revert it, just change the order of when you created the point. Either you do here, or like I said before, can do like this. Yeah, but I already did like this, so it just tell you you can use the fit function to revert to the reversing also. You give the source minimum and source maximum, and tell the node what is destination minimum you want. Then it will transfer 0 to 1 and 1 to 0, which inverted value. And then ramp it, ramp parameter, and change that to the spline ramp, so it's a single float. Then the next thing is create the band export. So not band, it's band export. This is export the value back to the attribute, which you put inside the name. It should be the same name, the curve U. So basically just import the value, attribute point, attribute value, curve view, and then doing the calculation here. Actually here what doing is just to remap the value, then export the value back to the curve view. Okay, go out, Now you will have the ramp here, so we can connect this to here. The same value, you see it's black because the ramp is all black. So if I move this, go up, see, yeah. So use that way we can control use that to control the size, the thickness actually of the fur. You want which size bigger, or which, or you want something inside, something like that. So actually right now the value, make the left side is tip and the right side is the root. Yeah, you can make the shape what you want. You can make more like a cylinder, probably like that, and cylinder on the top, and the button have a bigger size. Later we will use that value to shape the fur. Okay, so next thing we want to add is the attribute promote. What I want to do is to promote the source prime, attribute from point to the primitive. So you remember this attribute give the unique ID to each point, and after we create a line, I want to transfer this attribute for each line, so this ID will be the primitive ID, not only on the point. So each line will have their own ID. So go to the spreadsheet, go to the primitive, you will see, okay, we have that. So each line have their own ID. Okay, now we need to create the loop for each primitive to generate fur shape from each spline. So connect that, and we use a piece attribute which we promoted to the primitive. Use that one as a piece ID. Yeah, I will give some space here. Okay, now we need to create the circle. In the ZX plan, and the size, we need a smaller size transfer. You can use a primitive or polygon or nervous curve, anything you want. I just want to make it smaller and more division, so it's more smooth. Okay, so then we use a copy to points. Connect here, copy to points, and we'll see we copy the base point, makes that line. I would like to make this circle size scaled by the attribute we made here. It's called curve U. To make that work, we need to go back down to here. Just need to change this to the P scale. Then we'll create a new attribute, the point called P scale. Now you see, update the size. So the reason why we changed the attribute to P scale, then is the circle start scale themselves. It's because p scale is kind of like a default attribute to define the size of for each point. So when you do the copy to points, they will use this value to scale the object automatically. If you don't want the scale by that, you just remove that attribute. If you want to scale the object based on this value, you just fit this value before you do the copy to points. So I connect to the end, circle end, so you can see they create the slices for each floor. Oh, here we can change the shape. This shape actually I don't like it. I want to make it more simple size like that. Yeah, that is better. Okay. So the next thing we need to create the polyloft to create a geometry, not just slices. So connect here. Yeah, that is what we want. And make sure we set up this U wrap on to close the U direction. And there is no button and top. To make the volume, we better close that object, so we need to use a polyfill. Can make that a simple polygon. It should work. Okay. So now, yeah. You also can do some debug here to click the single path. You can go through all pieces in the loop from 0 to the maximum number for the debug. Now we need to convert that to VDB. So use the VDB from polygon. That converted to the volume. So the default stats is good, but we not use the VDB surface VDB. We use a fork VDB. So I have the density here. Okay, now we need to convert the volume texture to the slice textures. Then we can import to the game engine. There is a tool Houdini provided inside of the game developer tool site. You can install by use this update tool site. Currently I use 1.22, and I know in the new version Houdini 18 they change the name to SideFX Labs. Actually the inside the tool is similar. So here what I used is the game dev LP volume texture. It's the LP means render operation. So you can render this volume texture to slices texture. You can use the preview to see the result before you export it. Can confirm that is what you want. This result is pretty much I want. Resolution, everything is good. But here I want to explain how to use those parameters. This is sampling axis. Actually, I don't know why here whatever I select Y or Z same result. In my case, it should be sample only on the Y direction. So take a look here. I want the sample on the up, which Y direction. So whatever, they have the same result. And here is the resolution. That a little bit tricky. Some people don't understand. So the 64, because this is a volume texture, so they not only have X, Y resolution, but also have another direction is like XYZ, there should be same resolution. So this 64, which means they will sample the texture in each direction, each axis in the 64 pixel. So for example here, they will sample the texture for each one is 64 by 64, and they will sample 64 times on the axis you selected. Right now it's y-axis, so which means each slices will be 64 by 64 pixel, and you will have 64 textures here. Then you can define how many slices you want in the per line, in each line. So right now it's 8. So 8 multiplied 8 is 64, so it's the square size. If you say, okay, I want a 16, then you want to keep the same resolution, you have to increase that to the 1024 and reduce this 256 to contain all of slices in this texture. Or you want the lower resolution, which I want the 30, oh sorry, not this size is too big, so 32, and make it smaller. And also I want 8, that means you only need 256 and 128 to fit all variation there, because you only have 32 slices actually. So each line is 8, so you only need a 4 line. So if you want a higher resolution, it's not only higher the resolution of the each slices, but also the higher the sample times on the axis you point, so the whole picture will be bigger. So for example, if you want 128 and each line you still want 8, that will be much bigger than before. No, sorry for that. Probably more than that. Yeah. So you need sample 128 times. So think about each line have 8, so you need 16 lines. Yeah, that's a way to calculate what resolution you need. For sure, there are a lot of different ways you can generate this full volume texture. For example, here I used the Houdini guide group, which is a great tool to generate the hair and full curves to create the similar result as I did in this tutorial. So now we already prepared the full volume texture. In the next video, I would like to introduce how to generate the shell mesh in the Houdini. Okay, so see you in the next one.